So, if you're learning to code, you've probably hit that one big question. How do I actually get from, writing my first Hello World program to getting paid to do this for a living? Well, today we're cracking the code on that exact question.
I mean, this is the big one, right? You can follow all the tutorials you want, you can build little projects on your own, but making that leap, that jump into a professional software developer job, that feels like a totally different beast. So, what's the secret? What's the actual bridge that gets you there?
Well, it turns out the answer is a roadmap. We actually got our hands on a real university course syllabus, one that's specifically designed to get students ready for employment. And we are going to break it down piece by piece to find the exact blueprint for turning your coding skills into a career. Okay, so the first step on this journey from the classroom to a career is all about bridging that gap between what you know and what you can do for a company. And this syllabus, it shows us that the single most important piece of that bridge is the industry's undisputed blueprint, which is object-oriented programming, or OOP for short. And yeah, we are getting right to the heart of it here, because this is literally the language that modern software development is built on. So what is OOP exactly? Well, the simplest way to think about it is like building with digital Legos. Instead of writing one giant, long, messy script, you create these little self-contained objects. Each object holds its own data, and it knows how to perform certain actions. This is the fundamental idea that lets developers build massive, complex applications without the whole thing collapsing into a mess. Now, don't let these terms scare you off. They're not just academic jargon. These are the actual tools of the trade. Take inheritance, for example. That lets you create reusable code, so you're not constantly reinventing the wheel. Or exception handling, which lets you build tough, robust apps that don't just crash when something unexpected happens. Mastering these concepts, this is what separates a beginner from a pro. And hey, don't just take my word for it. The syllabus itself calls OOP the prevailing paradigm in modern software development. So the takeaway here is super clear. Learning OOP isn't just a suggestion, it's pretty much non-negotiable for a career in this field. Okay, so once you've got that core philosophy locked down, we can move on to building your pro toolkit. This is where we shift from the what to the how, turning those abstract ideas into the tangible, hireable skills that you see on actual job descriptions. Every single professional developer lives and breathes this three-step cycle. You don't just dive in and start mashing keys. First, you design a solution. Then, you write the code, and then you debug it to make sure it works perfectly. This course teaches that entire workflow for creating the kind of moderately complex programs you'd actually be building at a real job. And this is the end game. The whole point is to write code that's reliable, reusable, scalable, and robust. This is the language of professional software. See, anyone can hack something together that works once. A pro writes code that other people can understand, that can be easily updated, and that can grow without falling apart. That's what gets you hired. And look, mastering these concepts isn't just about theory. It means learning specific, marketable tech. You're learning how to handle errors gracefully, how to manage multiple things happening at once with something called threads, how to read and write files, and even how to build slick, modern user interfaces with JavaFX. This is the stuff that fills out a resume. So how does this all come together? Well, it's a powerful 1-2 punch. The concepts, the theory, that's taught in lectures, but the real learning, that happens in the labs. And this is so key. You're working with the exact same professional tools, the same integrated development environments like NetBeans or Eclipse that developers are using every single day out in the real world. All right, let's bring it home with our final section, the real-world test. Because look, having the skills is one thing, but proving you can actually use them in a way that mimics a professional setting, that's the whole ballgame. When you look at how students are actually graded in this course, something really jumps out. The team project. It's worth a solid 15% of the entire grade. That's not an accident. It's by design, and it makes it one of the most important parts of the entire course. And here's why that's so important. This project, it's way more than just another assignment. It is a direct stimulation of what it's like to work in a modern dev team. It forces you to collaborate, to communicate, to integrate your code with other people's code. It builds a real, tangible project for your portfolio, and it proves you can actually function as part of a team. Because let's be real, nobody in software works in a vacuum. And look, getting to the point where you can tackle a team project of that scale, it doesn't just happen.
It takes serious, serious commitment. In fact, the syllabus is very clear that students should expect to spend around 6 hours per week on independent study, alone. This just hammers home the level of depth you need to be truly workforce ready.
And all of this entire roadmap, it brings us to the ultimate question. The question that employers are really asking. It's not just, can you write code? The real question, the one that unlocks a career, is this. Is your code ready for a team?